Here is a number for you to hold. 14 billion years. That is roughly how long the silence has lasted. 14 billion years since the universe began, and in all that time, not one word, no message, no sign, no voice booming across the void to explain what any of this is for. And here is the strange part. Most people assume someone must have said something. Somewhere, at some point, an answer must have arrived. A revelation, a first cause that announced itself, a moment where the lights came on and the meaning was handed over. But look closely at what we actually have, and you find something else entirely. You find silence. A silence so complete, so uninterrupted, that it starts to feel like the loudest thing in the whole cosmos. So let me ask you the question that started all of this for me. If something set the universe in motion, why has it said nothing since? Why the quiet? Why the 14 billion years of absolutely nothing? I know how that sounds, like the opening of a sermon or the opening of an argument against one. It is neither. It is just an honest question about a genuinely enormous silence. And I think it is a far more interesting question than the people on either side of it usually allow. Because here is what almost everyone gets wrong. They think the silence is the end of the conversation, a wall, a closed door, proof of one thing or the absence of another. And I want to show you, step by careful step, that it might be the opposite. It might be the beginning of the most astonishing conversation you have ever been part of. So I want you to sit with that silence for a moment, not rush past it. Because I think if you sit with it long enough, it stops being empty. It starts telling you things, surprising things, things that almost nobody bothers to ask because they think they already know the answer. You do not, neither do I. And that, it turns out, is where all the wonder lives. I want to be clear about what I am not doing here. I am not going to tell you there is a God, and I'm not going to tell you there is not. I would not know how. Neither of those is the point. The point is the silence itself and what an honest mind can and cannot squeeze out of it. That is a smaller question than the one about God, but it is a real one. And real questions, followed properly, take you further than grand ones followed lazily. Before we can ask why the universe went quiet, we have to be honest about something harder. We have to be honest about how we know anything at all, not what we know. How, the machinery underneath the knowing. So let me build this from the ground up, one careful step at a time. And I promise you can follow every single step from wherever you are sitting right now, no equipment required. Just your own reasoning, which is more powerful than you have been led to believe. Start here. What do you actually have access to personally when you look up at the night sky? You have light. That is it. Light that left those stars a very long time ago and only just arrived at your eye. When you look at a star 1,000 light years away, a light year being the distance light travels in 1 year, you are not seeing that star as it is. You are seeing it as it was 1,000 years ago. The light is a messenger, and the message is always old. Sit with what that means. You cannot see the universe as it is. Nobody can. You can only see the past. The further away something is, the deeper into the past you are looking. Distance and time are the same currency out there. To look far is to look back. Let me make that concrete, because it is easy to nod at and miss. The sun you feel on your face is 8 minutes old. If it vanished right now, you would enjoy 8 more minutes of sunshine before you ever knew the nearest star beyond the sun is over 4 years away at the speed of light. Some of the stars you can pick out with your naked eye tonight died before you were born, and their light is only now finishing its journey. You are looking at ghosts, beautiful, faithful, ancient ghosts. Now, let me push that even further, because the scale is hard to feel, and it matters. Think of the big spiral you can just about see on a dark night, the nearest large galaxy to our own. Its light left it around 2.5 million years ago. When that light began its trip, there were no cities, no writing, no farms, nothing you would call human history. Creatures who were barely our ancestors walked the earth, and that light traveled the entire time, patiently, across an emptiness so wide the number stops meaning anything, and it arrived tonight at your eye, to be seen for an instant and forgotten. You are not looking at a galaxy. You are looking at a message posted before your species existed, delivered on time tonight. So already, before we ask about God or silence or first causes, we have hit a wall. The wall is this: information takes time to travel, and nothing travels faster than light. That is not an opinion. It is the most tested limit we have. Push against it every way we know how, and it does not bend. And it means there is a horizon on what you can ever know. Now push on that. If the universe is 14 billion years old, then there's a distance beyond which the light simply has not had time to reach you yet. Anything past that point is invisible, not hidden by dust or distance in the ordinary sense, invisible because the message is still in transit and always will be for as long as space keeps stretching. There is a boundary to the knowable, and it is baked into the structure of space-time itself. Here is the anchoring thought. We do not live in the whole universe. We live inside a bubble of the universe that light has had time to cross. Everything else is rumor. Everything else is beyond the horizon. And the horizon is not a thing we could travel to and peek over. It moves with us. It is a property of standing anywhere at all. Let me give you a way to feel how strange that horizon is. It is a little like standing in fog on a wide field. There is a circle around you where things stop being visible. Walk in any direction and the circle walks with you. You never reach its edge. It is not a fence. It is a feature of where you are standing and how far the light can carry. The cosmic horizon is exactly that, except the fog is the age of the universe itself, and no walking will ever close the distance because space is stretching faster than you could ever hope to travel it. There are galaxies out there whose light will never reach us, not because they are hidden, because the road between us is getting longer faster than light can run it. And that changes how you should treat every big claim, including the one in the title of this very piece. Because if someone tells you they know why the universe began, the first thing you should ask is simple. How could you possibly know that? What light carried that information to you? What observation could have delivered it? Where did the message come in? And what did it ride on to reach you? This is the heart of scientific literacy. And it is not about memorizing facts. It is about knowing the shape of your own ignorance, knowing exactly where the boundary sits between what you can check and what you are simply guessing. Most people never draw that line. They let the two blur together, and once they blur, you can be talked into anything. There is a beautiful tool for keeping them apart. Occam's razor. When you have two explanations for the same thing, prefer the one that needs fewer new assumptions, not because the simple one is always true. The universe is under no obligation to be simple. Prefer it because the simple one is easier to test, easier to break, easier to be honest about. It gives you fewer places to hide. Let me show you the razor at work on something small and homely, so you trust it on the big things later. Suppose you come home and a lamp is off that you left on. One explanation: the bulb burned out. Another: someone broke in, turned off your lamp, touched nothing else, and left. Both fit the fact of the dark lamp perfectly. But one needs a burned filament, which happens constantly, and the other needs an intruder with the strangest hobby in the world. The razor does not prove the burglar is not real. It says, do not reach for him until the lamp has had its say. That instinct, scaled all the way up to the origin of everything, is one of the most powerful things a person can carry in their head. And there is a companion idea just as important. A claim is only worth taking seriously if there is some observation that could prove it wrong. If nothing could ever prove it wrong, it is not telling you anything about the world. It is just decorating your feelings. That property has a name: falsifiable. A good idea sticks its neck out. It says, if you see this, I am finished. Come and try to kill me. Think about how demanding that is. A real idea about the cosmos volunteers its own execution. It tells you exactly what evidence would end it, and then it waits, exposed, for you to go looking. The ideas that survive that treatment are the only ones we should lean on. And the ideas that refuse to name their own weakness, that can absorb any result and still smile, those we should set gently aside, not because they are evil, because they are empty. Now hold that standard up against the silence, against 14 billion years of no message. Ask yourself, what would a message even look like? What would count as the universe speaking? Because if we cannot say what a signal would be, we cannot say whether its absence means anything at all. You cannot be disappointed by the failure of a phone to ring if you never had a number. And that question is harder than it sounds, which is exactly why it is worth asking. Would a message be words in a language? Whose language? Would it be a pattern in the light, a sequence too orderly to be an accident? Would it be a nudge on a passing rock, a signal written not in sound but in motion? You see the problem. Before we can be sure of a silence, we have to know what noise we were listening for. Most people who feel the silence never do this work. They assume the message would arrive shaped like the messages they already know, in words, in their own tongue, addressed to them. That is not a limit of the universe. That is a limit of the imagination we brought to it. That is the honest starting point, not an answer. A cleared space where an answer might one day fit. A place with an edge drawn honestly around it. And here's the thing that thrills me about that cleared space. It is not a defeat. It is the most exciting real estate in all of thought, because everything in it is still up for grabs. So let us go into it one revelation at a time. Imagine you are standing on the surface of the earth and you throw a ball straight up. It comes back down. Throw it harder, it goes higher, comes back down. Now ask the obvious question. How hard would you have to throw it for it never to come back? That number exists. It is called escape velocity. For Earth, it is about 7 miles every second. Throw something that fast straight up and it never returns. It leaves. Slower than that, gravity wins and drags it home. Faster than that, the thing is gone forever. There is no in between, no negotiation. The arithmetic decides. And notice, that number is not a mystery handed down from anywhere. You could work toward it yourself from the mass of the earth and how its gravity fades with distance. It comes from the ground up. Nobody has to be trusted for you to believe it. You can check the reasoning, and that is the whole point. Let me give you a feel for how that number changes, because it tells you something about the whole cosmos. On the moon, which is much lighter, escape velocity is only about 1.5 miles per second. You could very nearly throw a stone off the moon by hand if your arm were good enough. On the sun, escape velocity is hundreds of miles per second because there's so much mass pulling back, and there are objects out there where the arithmetic runs away entirely, where escape velocity climbs all the way up to the speed of light. At that point, nothing gets out, not even light. That is a black hole, and its edge, the point of no return, has a name. The event horizon, it is the same word, horizon, and it means the same thing it always means. A boundary past which the message cannot reach you. The cosmos keeps drawing these edges, and every one of them is made of the same simple arithmetic you just did with a ball and your own arm. Now here is where it gets interesting, and I want you to follow the turn carefully. Everything in the cosmos runs on this same simple arithmetic. Orbital mechanics, the rules that govern how things move under gravity, are not mysterious. They are the ball and the throw scaled up. A planet orbiting a star is just a ball thrown sideways so hard that it keeps missing the ground forever. That is all an orbit is, perpetual falling that never lands. The moon is falling toward us right now. It just keeps missing. So take that intuition and point it at something that actually happened. A few years ago, an object drifted into our solar system from somewhere else entirely, not from around our sun day. From the space between the stars, an interstellar object, the first we ever caught in the act. We called it Oumuamua. It came in fast, whipped around the sun, and left again, never to return. Its speed was above escape velocity for our whole solar system. It was a visitor, not a resident. And how do we know it was a visitor, not one of our own? Some rock kicked loose from the outer reaches, from the Kuiper Belt, the vast ring of icy bodies out past the last planet. We know from the path our own objects loop around on closed orbits. They belong to the sun's family. This one came in on an open track, too steep and too fast to be bound, a path that only makes sense if it fell in from the dark between the stars and is now falling back out. The geometry gave it away. Let me slow down on that because it is a lovely piece of reasoning and it is entirely something you could follow yourself. Everything gravity holds moves on a closed loop, a path that comes back around. Give something a little more speed and the loop stretches into a longer oval. Give it more still and the oval stretches further. Push it past escape velocity and the oval breaks open. It stops being a loop at all. It becomes a path that comes in once, bends around the sun, and leaves forever, never to return. When we tracked this object and drew its path, that path was open, broken, unbound. And there is only one honest place an unbound path can have come from: outside, from between the stars. And here is the part that made everyone lean forward. As it left, it sped up, just slightly, more than gravity alone could explain. A tiny non-gravitational acceleration, an extra push with no obvious engine behind it. Now sit with that. A rock from another star doing something the arithmetic did not fully predict. When the arithmetic misses, your attention should snap awake because the arithmetic is reliable. So either something is pushing or we are measuring wrong, and both are worth chasing. Your mind wants to run somewhere thrilling: a ship, a probe, a sail catching starlight, a message at last, the silence broken by a hunk of something crossing the dark on purpose. And I understand that pull completely. It is a wonderful thought, but watch how the reasoning has to work. Occam's razor steps in and asks the quiet question: what is the smallest number of new assumptions? And it turns out you do not need a message to explain a little extra push. You need ice, frozen gas that warms near the sun and turns straight to vapor, streaming off one side like the gentlest of rockets. Comets do it all the time, right in front of us, every year. That single, ordinary mechanism explains the extra nudge without inventing anything new at all. Think about how modest that push really was. We are not talking about a rock swerving or breaking. We are talking about a change in speed so small it took extremely careful measurement to even find a whisper of extra motion. And you already know a machine that makes exactly that kind of whisper because you have seen it in the night sky your whole life. A comet, growing a tail as it nears the sun, is doing precisely this. Warmed ice turning to gas, hissing off into space, and the gentle recoil of that hiss nudging the whole body along. It is the softest rocket imaginable, and it needs no pilot. So the ordinary answer was not a stretch. It was sitting right there in every comet we have ever watched. So the exciting answer and the boring answer both fit the same push, and here is the discipline that separates wonder from wishful thinking. When two explanations fit, you do not get to pick the one you like. You have to ask what new thing you could observe that would tell them apart. That is the whole game. Does it tumble the way a rock tumbles, or steer the way a machine steers? Does the push line up with the sun's warmth, or does it point somewhere a rock has no reason to point? Every one of those is a question the object itself can answer, if we watch closely enough. And here is what that little visitor really taught us, and it is bigger than any single rock. It taught us that the space between stars is not empty. Things cross it. Whole objects, flung out of other star systems, drift through the dark and occasionally pass through ours. There is traffic out there. Silent, tumbling, ancient traffic. Every star that ever formed a family of planets almost certainly threw some of them out. And those castaways are drifting still, and now and then one wanders into our little pool of sunlight. Let me make that thought bigger, because it deserves to be. Think about how our own solar system was built. A messy, crowded process with far more small bodies than survive today, flung around by the gravity of the growing planets, many of them slung clean out of the system entirely and lost to the dark. If that happened here, it happened everywhere. Every star with planets is a factory that made castaways and threw them into interstellar space. Multiply that by the hundreds of billions of stars in our galaxy over billions of years, and the space between the stars must be quietly thick with these wanderers. We only see the ones that happen to pass close enough and bright enough to catch. For every one we spot, Uncounted others slide through the dark unseen. The traffic is not rare. Our ability to notice it is what is rare. Then came another one. We named it 3I Atlas. Another interstellar object, another visitor on a path that will carry it back out into the deep, never to return. And each time one of these arrives, we get the same jolt of the same question. Is it just a rock? Almost certainly, yes. But we look, we measure, we check whether it accelerates in a way ice cannot explain. We ask what observation would tell the difference. We do not decide in advance. We let the thing tell us, and that is the honest posture. Right there. Open to the astonishing, but not gullible for it. Willing to be thrilled, but only after the ordinary explanations have had their fair hearing and failed. That is not cold. That is the warmest kind of respect you can pay to a mystery. You take it seriously enough to test it properly. That is the revelation hiding inside the arithmetic of escape velocity. The universe is not sending us messages, but it is sending us objects. And an object examined honestly tells you something a message never could. It tells you the truth, whether or not it means to. A message can be a lie. A rock cannot. Here is a second thing worth sitting with, and it has nothing to do with rocks. Point a telescope at the deep sky, at a patch that looks utterly black and empty, and hold it open. Let the faint light pile up, minute after minute, hour after hour. What comes out of that darkness is not nothing. It is galaxies. Thousands of them in a scrap of sky you could cover with a grain of sand held at arm's length. Whole islands of 100 billion stars each, crowded into a speck of black you would have sworn was empty. Let that sink all the way in, because it is one of the most staggering facts a person can hold. Pick the emptiest, blackest patch of sky you can find. Nothing there. Now aim the best eyes we have built at that nothing and wait. And the nothing fills with thousands of galaxies, not stars, galaxies, each one 100 billion suns. And that patch was the size of a grain of sand at arm's length. Now think about how many grains of sand it would take to cover the whole sky. The arithmetic gets away from you almost instantly. There is no empty sky. There is only sky we have not yet looked at hard enough. Now here is the trick that makes this a revelation and not just a pretty picture. The light from those galaxies is stretched. As the universe expands, the space the light travels through stretches too, and it pulls the light toward the red end of the spectrum. We call that redshift. And the amount of stretch tells you how far the light has come, and therefore how far back in time you are looking. More stretch means older light means younger universe. Let me make sure that lands, because it is the key that unlocks everything after it. Redshift is a clock and a ruler at the same time. Measure how far a galaxy's light has been stretched, and you have measured both its distance and its age in a single reading. The most stretched light of all is the faintest and the oldest, the light that has been traveling the longest from the youngest cosmos. To catch it, you need a machine tuned to the very reddest whispers. Here is a homely way to feel the stretch. You know how a siren changes pitch as it passes you. Coming toward you, it sounds higher. Going away, it sounds lower. The sound waves get stretched out as the source moves away, and the pitch drops. Light does something like it. As space itself stretches while the light is crossing it, the light waves are pulled longer, and their color slides toward the red. The longer the journey, the more stretch, the redder the arrival. So the reddest, faintest light in the whole sky is a package that has been in transit the longest, sent from the earliest moments we can ever hope to see. Read the redness, and you have read the postmark. So when we built a telescope capable of catching exactly that, the James Webb Space Telescope, we were building a machine to look further back than we ever had. Almost to the beginning, to the first few 100 million years after the Big Bang, when the very first galaxies were only just switching on. A time machine that works by patience and cold and enormous mirrors, parked far from the warmth of the Earth so it could see in the dark. And here is the turn. Nobody expected what came back. The early galaxies were too big, too bright, too grown-up, too finished, far too soon. Structures that should have taken billions of years to assemble were already there, fully formed. when the universe was still a toddler. It was as if you looked at a photograph of a newborn and found an adult staring back, massive, orderly, mature light, arriving from a moment when everything was supposed to be small and chaotic and only just beginning. Now sit with that, because this is exactly the kind of moment the universe lives for. A prediction met an observation, and the observation won. The picture we had of how galaxies grow patiently over vast stretches of time ran straight into light that did not care about our picture. And the light does not blink. The light does not apologize. It simply is what it is, and it was waiting there the whole time for us to build eyes good enough to catch it. And notice what did not happen. Nobody buried it. Nobody hid the surprise to protect the old story. The surprise is the point. This is the entire method laid bare. You have an idea about how the cosmos assembles itself. You make it falsifiable, meaning you say out loud what you would expect to see. Then you go and look, and when the sky says otherwise, the sky wins, and you get the exhilarating job of finding out why. Because there is a why coming, and we do not have it yet. Maybe the first stars formed faster than we thought. Maybe they burned brighter, hotter, hungrier, packing more light into less time. Maybe our clock for how galaxies grow was simply wrong. Maybe some of that early light is not as far away as its redshift suggested, and we are being fooled. Maybe there is a piece of physics in that early light we have not understood at all. Every one of those is a door, and every door is open right now. Nobody has walked through. That is not embarrassing. That is thrilling. And notice something about that list of maybes. Not one of them is a shrug. Each one is a specific, testable idea with its own fingerprints that a future observation could confirm or destroy. If the first stars burned brighter, we could measure the exact color of that early light and check. If some of it is closer than we thought, there are ways to catch the trick out. Every maybe on that list has volunteered its own execution exactly the way a good idea must. That is the difference between an honest mystery and a lazy one. An honest mystery hands you a menu of falsifiable answers and says, go find out which. It does not ask you to simply believe, but look at what this second revelation shares with the first. Again, no message. Again, the universe said nothing. It just did its work in plain view and let its own light carry the report across billions of years to a telescope we built to catch it. The universe did not explain the early galaxies to us. It showed them to us and dared us to keep up. And here is the thing almost nobody sees. That is a kind of honesty no voice from the sky could ever match. A voice could lie. A voice could flatter. A voice could tell you exactly what you wanted to hear, and you would never know. Ancient light cannot. It is the least deceptive testimony in existence because it was never trying to testify at all. It simply is what it is, arriving 14 billion years late, indifferent to whether we understand it, indifferent to whether it comforts us. The silence, in other words, is full of information. It is only silent if you were waiting for words. Here is a third thing, and it is the one that undoes the loneliness, or should. Ask the simplest question a curious person can ask. Are we alone? And instead of guessing, let us do what this whole way of thinking demands. Let us build the question out of pieces we can actually reason about, one honest piece at a time. There is a famous way of doing this, the Drake equation. Do not let the word equation scare you. It is not really maths. It is bookkeeping for wonder. It is a way of breaking one impossible question into a chain of smaller ones, each of which you can at least start to reason about. How many stars are there? How many have planets? How many of those planets sit in the Goldilocks zone, the region around a star that is neither too hot nor too cold, where liquid water could exist on the surface? And of those, how many actually grow life? And of those, how many grow life that builds things and reaches out? Here is why that chain is so clever. And it is worth walking slowly. Some of those links we now have real numbers for. How many stars there are, we can count. How many have planets, we have measured, and the answer turns out to be most of them. but other links are almost pure guesswork. How often does life actually begin on a suitable world? We have exactly one example, ourselves. And one example is a terrible thing to build a number from. So the honest use of the Drake equation is not to plug in numbers and announce an answer. It is to see clearly which links we have nailed down and which are still wide open. It sorts your knowledge from your hopes and lines them up in a row where you cannot confuse them. That is its real gift. A planet around another star, by the way, has a name, an exoplanet. And a generation ago, we did not know for certain that a single one existed. Not one. We assumed they were out there, but assuming is not knowing, and we held the line honestly and said, we have not seen one yet. Now we know of thousands of exoplanets, and the count climbs every year. Little worlds we detect not by seeing them, but by watching their star dim ever so slightly as they cross in front of it, or wobble ever so slightly as their gravity tugs it. Indirect, patient, clever reasoning that pulls whole planets out of a single star's flicker. Sit with how delicate that detection is, because it is a triumph of exactly the kind of reasoning we have been building. Nobody has ever seen most of these planets. They are far too small and far too faint, lost in the glare of their star. So how do we know they are there? We watch the star. When a planet crosses in front of it, the star's light dips by a tiny fraction, a fraction of a percent, and then returns over and over on a strict schedule. From that faint repeating dip, we can work out the planet's size, its distance from the star, and the length of its year. We never saw the planet at all. We saw its shadow and reasoned the whole world into existence from a flicker. That is what a trained mind can do with almost nothing. And when you follow the chain, the numbers get staggering fast. Hundreds of billions of stars in our galaxy alone. Hundreds of billions of galaxies beyond it. Planets everywhere. The Goldilocks zone is not rare. Warm, wet, rocky worlds appear to be common. So here is the turn, and is one of the sharpest turns in all of human thought. If life is at all likely, the universe should be teeming, crowded, loud with life, and older than us too, because many of those stars are billions of years older than the Sunday. Any civilization out there had a colossal head start. Time to spread, time to build, time to fill the sky, time, even at a slow crawl, well under the speed of light, to cross an entire galaxy many times over. Let me put a number on that head start, because it makes the paradox bite. Suppose a civilization could only creep between the stars at a small fraction of the speed of light. Slow, no magic, just patient ships or probes moving at speeds we can already imagine building toward. Even at that crawl, the arithmetic says you can spread across the entire galaxy in a few million years. That sounds enormous, but against the age of the galaxy, billions of years, a few million years is the blink of an eye. It is the last page of a very long book. So any civilization that got even a modest head start had oceans of time to be everywhere by now. The galaxy is old enough to have been colonized many times over, and yet the sky is quiet. That is the crux. That is what refuses to sit still. So where is everybody? That question has a name, the Fermi paradox. The gap between how full of life the universe should be and how empty it looks. And it is a genuine paradox, not a figure of speech. The expectation and the observation point in opposite directions and the space between them is one of the most honest mysteries we have. Both sides are built from reasonable steps, and yet they collide. Now bring in one more idea. Gentle but ruthless. The Copernican principle. The mediocrity assumption. It says, plainly, do not assume you are special. Every time humans have placed themselves at the center, the Earth at the center, the sun at the center, our galaxy at the center, we have been wrong. Every single time. So the safe bet, the humble bet, is that we are ordinary, a typical planet, a typical star, a typical corner of a typical galaxy. And notice the track record behind that principle, because it is what gives it teeth. We once knew with total confidence that the Earth sat at the center and everything turned around us. Wrong. Then we knew the sun was the center. Wrong. Then we knew our galaxy was the whole of creation. Wrong again. Spectacularly, once we learned those faint smudges were other galaxies entirely. Every time we placed ourselves at the middle of things, the universe quietly moved us to the edge. So when it comes to life, the humble bet, the bet that has kept winning, is that we are nothing special either. And that is precisely what makes the silence so hard to explain away. But if we are ordinary, the silence gets much stranger because ordinary things are common. And if intelligent life is common and the universe is old, the sky should be full of technosignatures, the fingerprints of technology, radio leaking, light flickering, waste heat glowing, something, and full of biosignatures too, the chemical fingerprints of life itself, gases in a distant atmosphere that only living things produce, or that living things produce far more of than dead chemistry ever could. And we are learning to read those atmospheres right now, starlight passing through the air of distant worlds on its way to us, carrying the chemistry of those worlds imprinted in it. Let me show you how that reading works, because it is almost too clever to believe. When a planet crosses in front of its star, a sliver of the star's light passes through the planet's atmosphere on its way to us. And the gases in that atmosphere each absorb their own particular colors, leaving little gaps in the light, like missing notes in a chord. Read which notes are missing, and you have read the chemistry of an atmosphere on a world you will never touch, trillions of miles away, from nothing but the light it filtered on its way past. If one of those missing notes turns out to be a gas that only life makes, or makes in quantities that dead chemistry never could, that would be a biosignature. A fingerprint of life, read from starlight. We are genuinely learning to do this now. And so far, quiet. The same 14 billion years of nothing. Sit with how sharp this is. Either we are wrong that life is common, which means something rare and precious happened here, some hard step that almost nothing else clears, or life is common and something silences it, or hides it, or keeps it from crossing the enormous gulfs between the stars. Or, hardest of all, it is out there, loud as anything, and we simply have not learned to listen yet, the way Oumuamua drifted through for who knows how long before we had eyes to catch it. Every one of those possibilities is astonishing. There is no boring answer to the Fermi paradox. There is only a menu of wonders, and we do not yet know which we live inside, and each of those possibilities carries its own weight. So let me hold them up one at a time. If we are rare, then this pale blue world is more precious than we ever dared imagine, a near miracle. And every act of carelessness with it is a kind of cosmic vandalism. If life is common, but something silences it, then there is a filter out there, a hard step that civilizations tend not to survive, and that thought should make us look very carefully at ourselves. And if they are simply out there, loud and unheard, then the silence is not the universe's fault at all. It is a gap in our own hearing, temporary, waiting to be closed by a better instrument and a patient eye. Notice that not one of those is a dead end. Each one is a door that opens onto more work, more looking, more wonder. And once again, notice the shape. No voice, no announcement, just an absence that refuses to be ignored. The silence is not empty here either. It is a clue, possibly the biggest clue we have ever been handed. An absence with information packed inside it, if we are brave enough to read it honestly. So step back now and look at the three things together. A rock from another star that sped up as it left. A telescope that found grown galaxies where infants should have been. And a universe that should be crowded with life, yet answers every call with quiet. Three completely different corners of the cosmos. Different tools, different distances, different kinds of question. And they all point at the same place. Here is what they share. In every single case, we went looking for a message and found something better. We found the universe behaving, not speaking, behaving, moving, glowing, growing, staying silent, all according to rules we can partly read and partly cannot. And the parts we cannot read yet are not walls, they are frontiers. There is a world of difference between a wall and a frontier. And knowing which one you are looking at is most of wisdom. Watch how each one refuses the easy story. The interstellar visitor could have been a ship. The arithmetic said, more likely, ice. The early galaxies could have been a mistake in the data. The light said, no, we are really here. Now explain us. The empty sky could have meant we are utterly alone. The reasoning said, maybe, or maybe you cannot hear yet, and both are open. Every time, the thrilling answer and the disciplined answer stood side by side. And every time the honest move was the same. Ask what you could observe that would tell them apart. Never decide with your hopes what only evidence is allowed to decide. And there is one more thing all three share, quieter than the rest, but maybe the deepest. In every case, the answer arrived as light or as motion, never as words. The rock told us the truth by how it moved. The galaxies told us by the color and the timing of their light. The empty sky told us by the exact shape of its emptiness. Not one of them addressed us, not one of them meant to be read, and yet every one of them was honest in a way no speaker could ever be, because none of them was trying to persuade us of anything. That is the strange gift buried in the whole business. The universe cannot lie to you, because it is not talking to you. It is simply being itself in full view and letting you draw your own honest conclusions. That is the convergence. The universe does not hand you conclusions. It hands you objects and light and absences. And it dares you to reason your way toward the truth without lying to yourself along the way. It is the greatest puzzle ever set. And the setter, if there was one, left no instruction. Only clues that never stop arriving in the mail every single night, if you know how to open them. And here is where the whole silence question turns inside out. You have been asking why the universe went quiet after the Big Bang. But look at what we have actually built. A telescope that reads light from the first galaxies. Instruments that measure the extra push on a rock from another star. Methods that could one day catch the breath of life in the air of a world we will never touch. We built machines to hear a universe that speaks only in physics. And the universe has been answering the entire time, in redshift, in acceleration, in the bending of light around unseen mass, the gravitational lensing that reveals dark matter, matter we cannot see but whose gravity warps the light of everything behind it. And in the exact pattern of the light in the cosmic microwave background, the faint afterglow of the Big Bang itself, still washing over us from every direction, the oldest light there is, and the hard edge of everything we can ever see. Let me pause on that last one, because it is the closest thing to a first word the universe has ever given us. The cosmic microwave background is a glow that fills the entire sky in every direction you point, left over from when the whole universe was hot and dense and bright only a few 100,000 years after the beginning. It is the oldest light there is. Before it, the universe was too thick for light to travel at all. So that glow is a wall, but the best kind of wall, a wall made of the earliest possible message, and we have read its faint pattern down to astonishing detail. It does not speak in words. It speaks in temperature, in the tiniest ripples of hot and cold across the sky. And those ripples told us the age of the universe, its shape, what it is made of. If you were ever going to call anything the universe's first utterance, it would be that ancient glow. And it is not a voice, it is light arriving on time, being exactly what it is. The universe never went silent. We just kept waiting for words when the whole time it was speaking in the only language that cannot lie, the language of how things actually behave. That is the cosmic perspective. Not that we are small. You have heard that 1,000 times, and it is not the point. The point is that we are the part of the cosmos that learned to read the cosmos. Ordinary matter on an ordinary world that woke up and started decoding the light. The silence was never the universe refusing to speak. The silence was us slowly, joyfully learning the alphabet. And we are still only at the first few letters. So let us bring it home. Let us go back to where we started. We started with a number, 14 billion years. and not one word. A silence so complete it felt like the loudest thing in the sky. And a question, why, if something set all this in motion, has it said nothing since? And the first thing we did was refuse to answer too quickly. We asked how we could know anything at all. And we found the hard limit. You only ever see light, and light is always old, and there is a horizon beyond which the message has not arrived and never will. We live in a bubble the light has had time to cross. So any honest inquiry has to begin by mapping its own ignorance, by being precise about exactly where the boundary of the knowable sits. That is not weakness. That is the strongest place to stand, because it is the only place you cannot be knocked off. We armed ourselves with two tools before we went in. The razor, that prefers the answer with fewer new assumptions, not because simple is always true, but because simple is easier to test and gives fewer places to hide. And the demand that any real idea name the observation that would kill it, because an idea that can survive any result is not telling you anything about the world at all. Hold those two tools in your hands, and most of the noise in the world simply falls away. Then we watched a rock, an interstellar object that sped up as it left, and how the disciplined mind held two answers side by side, the thrilling one and the plain one, and refused to choose until an observation could decide. And we learned the space between the stars is not empty. It carries traffic, silent, ancient, real, castaways from 1,000 other suns drifting through the dark, one of them now and then falling through our patch of light long enough to be seen. Then we looked at the oldest light we could catch and found galaxies too grown too soon. And we watched a prediction lose to an observation. Out in the open, nobody hiding the surprise, because the surprise is the whole reward. The sky said something we did not expect, and instead of a crisis, it was a gift, a door, a why we get to spend years chasing and are chasing right now. Then we counted. We broke the biggest question, are we alone, into pieces we could actually reason about. And the arithmetic said the sky should be crowded, and the sky looks empty, and that gap is a real paradox with no boring way out. And the principle that we are nothing special only made the quiet stranger and richer, not smaller. And all three converged. Every time we went hunting for a voice, we found behavior instead. Objects, light, and absences that carry more honest information than any announcement ever could. The universe was never silent. It speaks in physics. And we built, with our own hands, the ears to hear it. Slowly, imperfectly, but really. That is the answer that grew out of the silence. Not a voice from the sky, something better and stranger. A universe that tells the truth by simply being what it is, and a species that learned to listen. Now, let me be as honest as this whole way of thinking demands, because there is a great deal we still do not know, and I would be betraying every step above if I pretended otherwise. We do not know why the early galaxies grew so fast. That question is wide open, and the light that raised it has not finished being understood. We do not know the answer to the Fermi paradox. We do not know if we are rare, or common and unheard, or common and simply too far apart across the gulf to ever meet. We have not found a confirmed biosignature. We have not found a technosignature, and most of the universe, by mass, is made of things we have named but barely understand. Dark matter, which bends light through gravitational lensing, yet gives off no light of its own, and an even deeper darkness driving the expansion faster and faster. We named them. Naming is not knowing. A name is a promissory note, and we have not paid it yet. And I want to be honest about that discomfort too, because it is easy to gloss over. Most of the universe, by mass, is stuff we cannot see and do not understand. Let that sit for a second. We have mapped the behavior of the cosmos in exquisite detail, and the map tells us plainly that the biggest pieces of it are missing from our understanding. We can feel them by their gravity, we can watch them bend light, but we cannot say what they are. That is not a scandal. That is a frontier drawn honestly with our own hands, right across the middle of everything. And it is precisely the kind of edge that ought to make a curious person glad to be alive right now, while the map still has blank spaces on it. And the biggest question of all, the one in the title, what, if anything, set the whole thing going, may sit permanently beyond the horizon of light in the region no message can cross. That is not a failure. That is a map with an honest edge drawn on it, and the edge is exactly where the wonder lives. A map that pretends to have no edge is not a better map. It is a lie. So here is where I will leave you. Not with an answer, but with a better silence than the one we started with. A silence you now know is full. If you have stayed with me this whole way, through the light that is always old, and the rock that sped up, and the galaxies that grew too fast, and the sky that should be crowded and is not, then thank you, genuinely. You gave this your time and your attention, and time, as we said at the very start, is the one currency the universe is built out of. You spent some of yours here thinking alongside me, and I do not take that lightly. If this was the kind of thinking you want more of, the slow kind, the honest kind, the kind that treats you as fully able to follow any argument laid out with care, then I would be glad to have you subscribe and come back for the next one. No rush, no pressure, just an open invitation to keep sitting with the big quiet questions together and to keep learning the alphabet of a universe that has been speaking all along. Thank you for listening, and keep looking up. The light is still arriving.